Welcome back. In this lecture, we want to implement the scenario that I explained in the earlier lecture and do it using DLT pipeline. So basically, we will be creating our DLT pipeline. Before we start writing code, let's look at the scenario. The first step in the scenario is to ingest customers raw data and invoices raw data into these two tables from the landing zone, right? That's what we want to achieve, and then we will talk about what is next. So let's do these two things. As the first step, we want to ingest data from the landing zone into the customers raw, and similarly invoices into the invoices raw, and we want to do it using autoloader. So we will use autoloader in the DLT to ingest data from the landing zone. So let's start. So I am in my Databricks workspace. Let me go to my workspace. In my home directory, I have set up one simple notebook. Basically it's empty, and we will be writing our DLT code in this notebook. So the first step is to create your bronze layer table ingesting from the landing zone. And what do we want to create in the first? We want to create our customers raw table. So, but we haven't created any customers raw table. The table does not exist. So I want DLT pipeline or the DLT code itself to create the customers raw table and then load data into the table. So two things we need to define here. Create customers raw table, and then second part is load data into the table. So how to do it using DLT? DLT code can be written using a Spark SQL like syntax, and also can be done using Python. So in this lecture we will learn how to do it using SQL like syntax. Python we will learn later. So first step is to create a table for customers raw. So how do we do that in DLT? So we start with create or refresh. That's the difference. Normally in create table DDL we say create or replace, or simply create table if not exist. But here we will say create or refresh. So if table does not exist, DLT should create a new table. If table already exists, it should refresh the same table with the data from the source. So create or refresh. And then what do we want to create or refresh? We want to create or refresh a table, right? And then give a table name. So let's say table name is customers underscore raw, right? So create or refresh table customers underscore raw. But we want DLT to create a table and fill that using incremental approach. So what do we want to do? We want to create a streaming table. So that's the trick here. We have to write create or refresh streaming table customers raw, and that's the way we tell DLT to create or refresh a table which will be filled with a incremental data set. So we create a streaming table. What is the next step? We want to tell DLT from where to get the data for this table, right? So create the table is first part, but we also want to load the data into this table. So from where to get the data, and that can be told as simple as like select star from, and maybe in the from clause you can tell get it from the cloud files, right? So cloud files is our autoloader. So we have a cloud files function, and then in the cloud files function you can pass on the parameters to define your autoloader configuration and your landing zone directory. So the first parameter is your landing zone directory from where cloud files should start ingesting the data. So I'll simply paste the location here. So that's the cloud files location. We want to ingest data from the customers directory in the landing zone. And then next thing, immediately we will have to tell, okay, what is the file format? So maybe next parameter is CSV. So we tell what is the cloud file format. So data file is coming as CSV. What is next? The next step is to specify any necessary cloud files configuration or autoloader configuration. So with DLT, this cloud files function comes with some decent defaults. So it automatically configured with your schema evolution, automatic schema inference, and checkpoint for storing the schema across the micro batches. All that is taken care of by the DLT pipeline itself. And if required, we can give some additional configuration. So I want to give one configuration, so we learn how to give the additional cloud file configuration. So let me paste the code here. So any additional autoloader configurations can be provided as a map, and the map is nothing but a comma separated list of key value pairs, right? So you tell the configuration and give the value, and then if you want to give more configurations, put a comma, give the next configuration, and then value, and then comma, next configuration, and so on. So this is enough for our scenario. All I want to tell a cloud file to infer column types. Don't make everything a string. So try to infer column types. So that is pretty much all for ingesting data from a landing zone into customer's raw table. Rest all will be taken care of by the DLT itself. But I want to give one more field here. So we take everything from the data file, but I also want to add a current time stamp to this table, specifying at what time we ingested which record. So let me paste a code for that here. So I want an extra field called load time, which is current time stamp. So whatever time we ingest the record, it should be time stamped with the current time stamp, and we keep that as load time. So that's all. That's all the code I have for ingesting data into customers raw. Can you write the same kind of data ingestion code for invoices raw? Right? It's very simple. Next step is to ingest invoices raw. So let me paste code for the invoices raw. I'm not going to type it again. Here it is. Simple. Create or refresh streaming table invoices raw as select star, take all the fields plus current time stamp as load time. From where to get the data? From cloud files. This is the location. Data file is coming as CSV, and we want cloud files or autoloader to infer column types. So that's all. My bronze layer ingestion is done. What is the next step in our requirement? So let me go back to the slide and see what is the next requirement. Okay, so here we are. So next step is to read data from customers raw and apply some data quality checks to filter out the poor quality records and fill data into customers cleaned table. So we want to create one more table. Table name is customers cleaned, and fill data from customers raw into the customers cleaned, filtering out some poor quality records. So how to do that in DLT? That's the next step. So let's try learn that. So I'm back on my same DLT pipeline notebook, and next step is to create your silver layer tables reading incremental data from bronze layer. So I'll write code for that here. How to write DLT code? There are always two parts of DLT code. You create a table and then fill the data into the table, right? So we want to create a new table. and table name is customers cleaned. I hope you already learned how to create tables so in DLT. So I'll simply paste that line here. Here it is. Create or refresh streaming table, customers cleaned. The entire silver layer we want to create using incremental data processing approach, right? So all the tables in the silver layer are going to be a streaming table. And this is how DLT knows that this table should be created using incremental data processing. So customers cleaned will become an incremental table or simply called a streaming table. But we also want to implement some data quality checks, right? So in DLT, in the declarative ETL, data quality checks are performed through expectations. What is an expectation? It is simply a constraint. Like in traditional relational databases, we implement constraints, right? So we add constraints to this table, and those constraints in DLT are known as expectations, simply called data quality expectations. So how do we define expectations for this table? Maybe put a parenthesis here, and in the parenthesis we will define the expectations. So let's define it. Expectation is defined, or the constraint is defined as constraint, and then give a constraint name. Let's call it valid customer constraint. And then we say, okay, we expect this constraint what? We define the condition. For example, I want customer ID to be non-null. So simply say customer ID is not null. Simple, right? So what we are doing, we are defining a constraint. Constraint name is valid customer, and we expect that customer ID is not null. So if customer ID is null, constraint is violated. If customer ID is not null, constraint passed. But what do we want to do after that? What do we want to do if constraint is passed or constraint failed, right? So that we can define here on violation. What do we want to do? Let's say drop row. That's all. So what we did so far looks very simple. Create or refresh a streaming table. Table name is this, and this table has one constraint only, valid customer, and this constraint expect this rule to pass. And if this rule is violated, drop the row. Leave that row. Do not insert that row into the customers cleaned. That's all. We are done defining a table, and we are also done defining a data quality expectation. Now we need to fill the data into this table, right? So we need to specify the second part, how to fill the data. So that's as usual, as like we did earlier, as, and then we do the select expression where to get the data. So as let's say select a star, or maybe you can type specific column names, assuming that there are so many columns coming about the customer from the source. We don't want to bring all the columns. We are interested only in a specific column, so you can do that also. So let me paste a select expression here. Simple. So I'm bringing customer ID and renaming the column as customer underscore ID. So I'm taking customer name and renaming that name as customer underscore name. So basically I'm also implementing a standardization of the column names, and then load time. And from where this data will come from, and this data should come from the customers raw table, from my bronze layer table. So from this table, but this table is a DLT table. It's a streaming table created by the DLT pipeline. I'm not specifying any catalog name or database name here. So where do we find this table? In which schema or in which database I can find this table? So tables that are created within the DLT pipeline by the DLT itself can be referred using a keyword called live. Live is like a intermediate or temporary schema created by the DLT where all these files can be found or referred. So all these tables that we are creating within the DLT pipeline itself can be referred using live dot table name. So live is like a schema here. And since my source table, this table is a streaming table, I'll also wrap this table name inside a stream. So I'll simply say stream, and that's all. So that's how we refer DLT tables within the DLT pipeline. So customers raw table is created within the DLT pipeline, so I can refer it using live.customers raw. And since it is a streaming data set, it's an incremental table, so I have to specify it with a stream. To read it as a streaming table means I want to read it in incremental, using incremental approach. I don't want to read the entire table. I just want to read the incremental data from this table, and that's why this stream is important. If you don't give that stream keyword here, if you don't wrap it, then this code will try to read the entire table, but we don't want that. We want to read only the incremental data, and that's why I'm putting a stream here. And that is kind of all. My customer cleansed or cleaned table is defined in the DLT. Similarly, you can define your invoices clean table also. Code is similar. I hope you can write that. So let me paste that code here and quickly walk you through the code. That's the code for invoices cleaned. Looks long, but there is nothing much new here. So what I'm doing, create or refresh streaming table, because this table also I want to build as a streaming table using incremental data. Table name is invoice cleaned, and within this pair of parentheses I'm defining a constraint. So constraint is valid invoice and quantity. What is the rule that I expect it to pass? Rule is simple: invoice number is not null and quantity is greater than 0, right? So both the conditions should pass. On violation, drop the row. So we drop this record if these two constraints failed, and that's how we check the data quality. But I also want this table to be partitioned, so that flexibility is also there with the DLT. It's not like that you can create table only. You can also create a partitioned table. So I want this table to become partitioned on invoice year and country, 2 columns. The reason is that this is my fact table. It's going to be large. Fact table is assumed to consume and collect lot of data, so it's advisable to keep this partitioned so that rest of the queries, the aggregation queries, can perform faster. So I'm implementing partition. Where is the data coming from? This table, as select, and simple. I have a select expression, and this select expression gives me opportunity to implement some kind of transformation also. So if I'm simply doing simple transformations like invoice number renamed as invoice underscore number, this column is also renamed, right? Quantity and invoice date, maybe it is coming as string, because while building my bronze layer here I have not defined date time format and all that, so that it can infer the date time columns correctly. So I'm assuming that invoice raw will infer the date time column as a string. So I want to fix that. So I know invoice date will be inferred as a string, so I want to fix that, convert it into a to date and rename the result as invoice date. Similarly, unit price, customer ID, country, all that fine. Invoice date, again I'm adding two extra columns, so invoice year, invoice month. So how to derive the value for invoice year? Taking invoice date, converting into a proper date, and then taking year part of the date of the invoice date and keeping it as invoice year and then invoice month. And finally, I also take the load date or load time stamp from the bronze layer. And this is the column which I am using for first level partitioning, and country column for the second level partitioning. And source for this is invoices raw. It's created in the DLT pipeline itself, so I can refer invoices raw using live.invoices raw. If I don't use live dot, then maybe pipeline will try to find this table in my default database, right? But I know this is not created in the default database. It is created as part of the DLT, Delta Live Table pipeline, so I can refer it using live schema. And I don't want to read this table full. Every time I refresh this clean table, I don't want to read the entire table. I only want to read the incremental data. So that's why I am using a stream here. So read only incremental data. That's what this stream tells. And that's all. We are done with the first intermediate table or high quality data table for my silver layer. What is the next step? Let's go back to our diagram and try to see what is the next step. So here is the slide. We prepared these two tables, right? Customers cleaned and invoices cleaned. Next step is to prepare the customers table and similarly invoices table, but these two are completely different. Customers table should implement SCD type 2. So when updated customer information comes, we want to implement SCD type 2 for the update, right? And you already know what is SCD type 2. What do we do in the SCD type 2? The old record will be closed and marked inactive with a timestamp, and then new updated information about the customer will also get inserted in the customers table, and it will be time stamped, marked as active. So it's like till 15th January the old record was active, and from 16th January the new updated information has arrived. So customers information is active from 16th January onwards using the new record. So that's what we want to implement here. So let's finish this part and then we will come to this. Let's code this because this is completely new. We want to implement SCD type 2. Okay, so step 3 is to build your SCD type 2 dimensions using CDC from silver layer. So how do we do it? Again, there are only two parts of every DLT statement. Part 1 is create the target table, and then part 2 is fill the data into the target table. We specified two things. So first part is create the target table. Target table name is customers. So how do we create the target table? Same statement. Let me paste it. Create or refresh streaming table customers. This table also I want to be an streaming table which will be filled only with the incremental data. It won't be refreshed again and again completely. So only incremental data will be processed. So create this, and then we put a semicolon here because we want to write a separate statement for how to fill, what data to fill in this table. Now earlier we were writing it create or refresh table or a streaming table invoices cleaned, give any constraint if you want, and after that we in continuation of the same statement we give how to fill data using as and then build our select expression. right? But here what we want to do, we want to implement SCD type 2, which behind the scene is done using merge statement or a complex logic plus a merge statement, because it is duplicate removal, and duplicate removal is done simply using the merge statement, right? If record already exists, update that record, and if record does not exist, then insert that record. That's what the merge statement does. So in DLT, applying merge statement comes with a separate syntax, a different syntax. So let's try to learn what is the syntax for implementing the merge statement, and we will put up some configuration so that that merge statement is extended to implement SCD type 2. So let's try to learn that. So statement is as simple as apply changes into which table? Into customers table, right? But it is a live table, so live dot customers table. So apply changes into customers table, and then we tell what is the source. So from, and from is my customers clean table, right? So but I want to read only incremental data, so I'll put it in a stream function or wrap it inside the stream, and then it is DLT created table, so I can refer that using live dot customers clean. So apply changes into this target table from, this is the source table, and what is next? You know, merge statement. Merge statement, we define the join condition, how to find the record already exists or not, right? So to define the join condition, we simply say, okay, keys, and tell what is the unique key. It's a single column or a composite column. So whatever the unique key is there in your customers table, that you have to tell here. So what could be the unique key? Maybe customer ID. That is what we want to be non-null always. So let's make customer ID as unique key. So key is a single column key, which is customer ID. So we are kind of writing merge statement in a different syntax, in a declarative syntax. We are not telling how to merge. We are simply saying apply changes into the customers table from customers clean table using only incremental data, and for merging, match the records using customer ID. And what is next? What to do next? Next is a very powerful feature of DLT apply changes. We call it sequence by. Sequence by, and in sequence by I want to tell one field kind of load time, right? So sequence by load time. What does it mean? If we have received two updates for the same customer, right? One is update at maybe 10 a.m., another update at maybe 11 a.m. So we will have two updates, and target is one record. So which one of these two we should take for building our SCD type 2 dimension? Maybe you should first implement it using first record, then implement it using the second record. First record is 10 a.m. record, second record is 11 a.m. record. So all that makes your logic very complex. If you are coding for that, you will have to implement a sorting and then implement it step by step for both, or ignore the first one and implement the second one. But DLT is a declarative tool. We simply tell, okay, if there are duplicate inputs for the same customer ID, sort them by load time. and then implement the SCD type 2. And that's what the sequence by will do. So it's a magical, very powerful feature of DLT. And what is the next? We are done. But we need to tell that we want to implement SCD type 2 because DLT gives you options for implementing SCD type 1, SCD type 2, CDC, simple, override the same record, CDC, multiple options. So we want to tell, okay, in this scenario, for this customer's table, we want to implement SCD type 2. So that can be told as is stored as SCD type 2, right? And put a semicolon. We have two statements in this single cell. This is the first statement, this is the second statement. So it is mandatory to use semicolons to separate these. And that's all, we are done. Build your SCD type 2 dimension using your silver layer table, which is this clean table into your final dimension. Super simple. And we will run it and see how it implements, what is the result. But we are done. So we are done with the customer dimension. What is the next step? Let's go back and look at our requirement diagram. So here it is. So we built this. Now next one is this invoices. So we want to build the invoices fact table. And in the fact table, we don't want duplicates. We want one record for one invoice, which should be the latest information. It is possible that invoice is coming as update, right? So it is possible that you got 9 a.m. you got one invoice, and 9:15 you got another update for the same invoice ID, and that's possible, right? So how do we handle that? Simple. Merge the 9:15 record after the 9 a.m. record into the same table and override the data or update the existing record. And that also can be done using merge statement. Merge means merge into the target table using the source records, and if record is matched, update that same record. If not, insert it. So how do we implement merge? Simple merge, which is not a SCD type 2, which is kind of change data capture, right? So how do we do that? Let's do that for invoices. So here I am, and the next step is to merge into fact table using CDC from the silver layer. So how do we do that? Again, two steps: create the table, create or refresh the table, and then step 2 is to provide the details how to fill data into that table. So let me copy paste the code for creating the table. That's simple. Here is the code. Create or refresh. I want this also to be a streaming table which should be filled using incremental data. Table name is invoices, and I want this table to be partitioned by invoice year and country. So earlier also we tried to partition the invoices cleaned table using invoice year and country. Same way we also want to partition our fact table using invoice year and country. So I'm specifying that option. So table is defined. What is the next? The next step is to provide details how to fill data into this table. So let's do that. So in this case also we want to implement merge statement. It's not a single select statement. So in DLT there are only two syntaxes. One is your select, read data from source, do some transformation as part of the select expression, and write it into the target table. In our case we are reading from one table, but you can do all kind of things, like you can join two tables, you can do an aggregation, whatever you want to do. You have the full flexibility of the SQL expression and build complex transformations. Other option is apply changes, which is a kind of merge statement. And with the merge statement or with the apply changes, you have multiple options. We used SCD type 2 here, but this time we want to implement a simple merge statement. So syntax is same, apply changes. So let's do apply changes into what is the target table. This is my invoices table, same like earlier. But it is a live table. I can access it using live dot, and then we tell data, where is data coming from. So from, and from where data is coming from invoices cleaned, right? And I want to read only incremental data, so put a stream there and use live dot invoice stream. So data is coming from invoices cleaned, and then once we have the data, we have to tell what are the keys for matching, right? So what is the key in the invoices? Maybe let's go look at it. Maybe invoice number is a good key, right? So we put invoice number here, but let's think it about it little carefully. Invoice is coming with the invoice number. Looks like for each invoice we will get multiple records, right? For each invoice, basically this is invoice line item. So if in one invoice there are 3 items sold, we will get 3 records: one line item, one record, second line item, second record, third line item, third record. And that's why we have a stock code and description, quantity, price, all those details are there. So basically invoice number is not a unique key, so I'll have to use some composite key. So I think using a stock code and invoice data is a composite unique key for my invoices record based on my data set. So that's how you can use composite key for matching, right? So that's pretty simple. So we defined apply changes into this, from this table, match it using this, and it will automatically assume if not matched, when not matched, insert, when matched, update. That's what we want merge statement to do, right? But we still have the sequencing problem, right? What if 2 updates arrived for the same invoice? One update arrived at 9:15, another at 9:18. Do you want to implement 9:15 first and 9:18 second? Yes. If we implement 9:18 first and then 9:15 second, then we are overwriting the new information with the old information, which will corrupt our data. So sequence is a very critical thing here. So whenever you are doing merge, even if you are manually implementing merge in your fact or in dimension, you should implement a sequencing logic there. But DLT gives us an easy way to implement sequencing. So sequence by, and what is the field here? You have to have some field which identifies the order in which the transaction happened. I'm using load time here, but ideally your record itself should have a created time stamp, right? And you can use that for sequencing. But since my input dataset doesn't come with the created time stamp, I purposefully created load time stamp, so at least I know what time which record I'm loading first and which record I'm loading second, and then I can do sequencing based on the load time. But in best case, your data should tell itself that what time this transaction happened and which transaction happened first and which transaction happened second. And that's all. We are done with that. Put a semicolon and we are done with implementing our fact table. That's all. So what is next? Let's go back to the diagram. So we kind of implemented all up to here. We implemented bronze layer, we implemented a silver layer, We haven't written more than 50 lines yet. The last step is to create this gold layer table, and we want this table to refresh itself fully. So full refresh means what? You have two options. You can create a view. So view is always refreshed when you query that view, right? When you use that view. So, but view has a disadvantage. Every time you touch that view, the query is fired, and it will go and query the base tables once again, right? So views are typically slow. What is the alternative approach? Think about the databases or data warehouses. We have materialized views, right? So materialized view is filled with the data. So it is refreshed when there is any change in the source table. We refresh the materialized view, and once it is refreshed, your customers or consumers can query the materialized view, and it should perform fast, because this is a reporting table which is a small aggregated table, and it should perform fast. So full refresh in DLT is done using implementing a materialized view uh, for your table. So in this last step, what we want to do, we want to create a daily sales UK 2022 materialized view. So far we have been creating streaming tables, which are incremental tables. Those are tables, right? We load data into those tables, and those are incremental tables. But this one we want to implement as a materialized view. So let's see how to do that. You can also implement it using view, but we prefer using materialized view. So let's see how to do that. So here I am. The last step is to materialize your gold layer summary using silver layer fact. So how do we do that? Simple. Here also, all I have to tell, create or refresh a table, and how to fill data for that table. So we'll give a SQL expression for that. So let's do create or refresh. What do we want to do? Earlier we wanted to do an streaming table, which is an incremental table. This time we want to do a materialized view. So the keyword in DLT for creating a materialized view is live. So we want to create or refresh a live table, and table name should be daily sales UK 2022. So simple. We want to create or refresh live table, and this live represents a materialized view. If you want to build an incremental table, you will build a streaming table. If you want to create a materialized view which is fully refreshed every time there is a change in the source data set, you will create a live table. That's why the live means it is live. It always refreshes and gives you the latest live state of your data. And once this is done, you can specify how to create that materialized view. So and put up your aggregation query. That's all. So let me paste the aggregation query here. Here is the select statement. So what do we want to do? Select country, invoice year, invoice month, invoice date, and sum of quantity into price, round it to two digits, and rename it as total sales. So basically we want to calculate total sales by country, invoice year, invoice month, and invoice date. And since it is only for UK and year 2022, I want to apply a filter where invoice year is equal to 2022 and country is United Kingdom. So that's all. And for creating this sum aggregate, you have to group by. So group by country, invoice year, invoice month, and invoice date. That's all. One more important thing, we don't want to create this aggregate using incremental data only. I want to create aggregate reading the full record. So I'm reading full invoices table. So I'm not using stream keyword here. So that's all. We are done with the writing DLT code. So I hope you learned how to use declarative ETL in Databricks. What is the Databricks DLT pipeline code? So we are done with the first part. If you recall your earlier lectures, we talked about DLT can be implemented in two stages. First stage is to write your declarative ETL code. We are done with that first stage. Second stage is define your DLT pipeline using the Databricks workflow UI. So that's what we are going to do in the next lecture. Define your DLT pipeline so that it can be scheduled or executed on a regular basis, or can be scheduled to run as a continuous pipeline. All that we will learn in the next lecture, and test this code also. See you again. Keep learning and keep growing.